solve the ODE, ordinary differential equation, by the method of variation of parameters. So our equation is y triple prime plus y prime equals tangent t, and t is in between 0 and pi. So we have a non-homogeneous, because the right hand side has a function, not 0, non-homogeneous third order linear differential equation. Okay, to solve this, we first consider the corresponding homogeneous. So make right hand side 0. So y triple prime plus y prime equals 0. Okay, this is homogeneous, and we know how to solve this. To solve, we first find the corresponding characteristic equation. So R3 plus R equals 0. Now we solve this equation. R3 means it's a cubic polynomial in R. We should have 3 R values. So R cube plus R, factor R out, R square plus 1 equals 0. So from this factor R equals 0, so R square plus 1 equals 0 gives plus minus 1i. And now we have 3 zeros. Based on these 3 zeros, we have 3 solutions. So e raised to 0t, which is 1. So the first solution is 1. And the second solution is, we know when we have complex roots, that's cosine sine. There is no real part. It is 0 plus 1i. So cosine 1i, so cosine t. And y3 is sine t. So we have 3 solutions. Then we can write down the solution, the general solution for this homogeneous, which is a complement, which is the complementary solution for the original. So then YCT, complementary solution of the given, the original ODE, is the linear combination of these 3 solutions. So C1 times 1 plus C2 times cosine t plus C3 times sine t. Okay, this is just the solution of homogeneous part, which is the complementary solution of the original ODE. Okay, that's YC. Now we need to find a particular solution, and the sum of this particular plus this complementary will be the total solution, the general solution of the given original equation. Okay, so we take YPT, a particular solution, as we vary C1, C2, C3 by constants, not the constant, they are constants, by variables, functions of t. So this will be u1 plus u2 cosine t plus u3 sine t, where these u1, u2, u3 are given by this formula. So ui, obviously I maybe 1, 2, 3. This is given by the variation of parameters formula as gt, where g is the non-homogeneous part. You know, the tangent t right hand side in the original ODE, that's the g part. Okay, that's the g, times wi, so u1, this will be w1 over, I'll tell you about w1 in a moment, over wt, and obviously integration dt. Okay, so this w is the Wronskian of these 3 solutions, 1 cosine t and sine t. Okay, 1 cosine t and sine t. The Wronskian of these 3 functions is w, and wi means I equals 1 to 3. w1 is the same Wronskian w, replace the first column by 0, 0, 1. So w2 will be same Wronskian, but replace the second column by 0, 0, 1. So I'll write here and I'll show you. Okay, so the w is the Wronskian of these 3 functions, 1 cosine t sine t. We write those 3 functions here, their derivatives and their derivatives of derivatives. Now we calculate this determinant. So to calculate this determinant, we can expand along first column, 1, 0, 0, and we don't have to do anything for 0, 0, just 1, and we delete row and column containing 1. We write down the 2 by 2 matrix here, 2 by 2 determinant. So 1 times this 2 by 2, we multiply here sine square minus negative cosine square. That means plus cosine square. Sine square plus cosine square is 1. Okay, that's the W. Now look at this formula here. So we have to find U1, U2, U3. So that requires us to calculate W1. So W1 is same determinant this, but replace 1, means first column by 0, 0, 1. W2 replace same thing, but replace the second column by 0, 0, 1. And W3 will be same determinant, but the third column will be 0, 0, 1, and we expand like this. So W1 is this same determinant, but the first column is now 0, 0, 1. Again, we can expand along the first column to determine this determinant. So 1, and we delete the row and column containing that. So cosine, sine, negative sine, cosine here. Then we find this 2 by 2 determinant, multiply minus this, so we get 1. W2 is W same, but replace the second column by 0, 0, 1. And we can expand along 1, delete the row and column containing 1. So 0 cosine, 1 negative sine here. This 0 minus cosine, this negative cosine. And W3, W, but the third column is now 0, 0, 1. We can expand along this 1, delete the row and column containing 1. So negative sine t 0, negative cosine t 1, multiply negative sine t minus 0, just negative sine t. So we have now W1, W2, W3 and W. So we go back here and find U1, U2 and U3. And we plug those U1, U2, U3 here in this solution. Then we get YP. YP plus YC will be the solution of the given original ODE. Okay, so let's find U1, U2, U3. So now U1 is, and U1 is integral of GT times W1 over W, and GT is the non-homogeneous term of the original question, that's tangent T times W1. Look at above, 1, W is also 1. So we have integral of tangent T, and we know that integral of tangent T is negative natural log of cosine T or just natural log of secant T. And we don't need absolute value. In the question, if you look at T, T is in between 0 and pi over 2, or you can always write this. That's U1. Similarly, let's find U2 and U3. So U2 will be then integral of GT, which is tangent T, times W2 now. And if you go up and see, W2 is negative cosine T over W is 1 dt. This negative can be pulled outside. Now we need to evaluate this integral. And tangent is sine over cosine. Now cosine, cosine cancel. Sine over cosine, cosine cancel. So that's the negative sine T. And antiderivative of sine is negative cosine, but with negative is simply cosine. And let's find U3. That's integral of GT, which is tangent T, times W3. If you go up, W3 is negative sine T over 1 dt. Now let's find this. This is sine over cosine. Let's put negative outside. Okay, this is not that simple now. Sine over cosine, and we have sine times sine. Sine is squared over cosine. Now let's separate sine into cosine, so negative. Express sine square in terms of cosine. We know that sine square is 1 minus cosine square t over cosine t dt. Separate into two fractions, negative is still outside. 1 over cosine, that's secant t, minus cosine square over cosine, just 1 cosine t. Now let's find this integral. so negative outside, and antiderivative of secant, okay, which is not easy. Antiderivative of secant is natural log of secant t plus tangent t. Since our t is in between 0 and pi over 2, we don't need absolute value, but let me write anyways, minus antiderivative of cosine is just sine t, and plus c is not needed, and we can distribute this negative sign, so this becomes negative and this becomes positive. So now we have u1, u2 and u3, and thus we can write down a particular solution ypt. If you recall correctly, that was u1 plus u2 cosine t plus u3 sine t, and we just found u1 is natural log of secant t. This is natural log of secant t plus u2, that's cosine t, and times cosine t, that becomes cosine square t, plus u3 times sine t. So this one times sine t, so minus, okay, minus plus sine t, so we are multiplying this by sine t. Minus plus, let me write that, sine t, we are multiplying by sine, so sine square t minus sine t times natural log of secant plus tangent. Okay, so this is a particular solution, and yp plus yc will be the whole solution. So finally, hence yt, the total solution, the general solution of the given or the original ODE is yc plus yp, and we have found yc and yp above. So you can rewrite, but that's basically just rewriting, where yct was given above, that was c1 plus c2 cosine t plus c3 sine t, and yp is just found here. By the way, cosine square plus sine square is 1, okay, or we can write yc and ypt are found above. You can simplify cosine square plus sine square combined 1, and in yc we have c1 plus 1, that will be a new constant. If you like to write, you can simplify, but this is it.